Hi guys, क्या हाल चाल है भाई? Hello everybody. Please tell me if I am audible to you guys or not. Please tell me if I'm audible to you guys or not. Hello guys, hello everybody. Please tell me in the chat box that if I am audible to you or not. Type yes if I am audible. Please type yes if I'm audible. Yes. Very good, very good. I'm so very happy to be on the Catalysis channel. This is me, Saurav Goswami, and I am your inorganic chemistry teacher. मुझे पाहुल ने और I'll talk in English most of the time. Paul has asked me to come on the channel because I love his work and the amount of effort that he puts in. All of you guys, hats off to the amazing work that Pahul does, and to you guys who have always made everything amazing. Okay, you have made everything amazing on his channel. I completely admire you guys that you have come in such large numbers today. Very nice, very lovely. My name is Saurav. I'll give you a brief introduction about myself going forward, but on the surface, I am from NIT Rourkela. I passed out my masters in the year 2008, and I would love to interact with you guys. I usually take classes on the platform, mostly the in-house classes. A lot of students might be knowing me, but I take usually the toppers batch, Eklavya, and so on and so forth, KVPY classes. And out of my busy schedule, I have come here to fill the void that Pahul will be leaving because he's going on a break. Guys, please do remember, everybody needs a break. Pahul is on a break. He'll come back after 2 weeks. So just go a little easy on me. And please do remember that Pahul will come back and he'll start teaching you guys. Okay, Pahul will come back and start teaching you guys. I'll take up your questions going forward. But today I have decided to talk to you guys about some amazing stuff that inorganic chemistry is gonna offer you. And so I would request you guys to be attentive, listen to everything that I'm talking about like a story. एक कहानी के जैसे सुनिए इसको. Okay, more so it will be amazing if you interact with me on the academic front on the chat box, and let's go. Thank you Kaustav, thank you Nishit, thank you. Very nice to be here on the Catalysis channel, and it's lovely to see you guys be a part of it for a really long time. I'm a new member, so please do a little less ragging of mine. Okay, chalo, very nice, very nice. Chalo, so let's start today's discussion. And let's start talking about something. Let's start talking about something that is very close to my heart, that is chemistry. Okay, let's start talking about something which is very close to my heart, and that is chemistry. Also, please remember that there's a 15-second lag. That means if I say something on this end and there is a lag of 15 seconds, so please don't mind it. Okay, so if there is any issue, please do let me know. Okay, so today's session is a very general one, very general one, but if I would say it is more designed for 12th standard students. However, everybody can enjoy, everybody can sit and relax and listen to what I am gonna talk about. So my discussion today is about 5 amaze bombs in inorganic chemistry. 5 amaze bombs in inorganic chemistry. Okay. Sir, tum in left side, please. Okay. Very thanks a lot, SM. Thank you a lot. So 5 amaze bombs in concepts in inorganic chemistry. Inorganic chemistry is a very dreaded topic. However, I would want to make it as interesting as possible for you guys. So let's start with the first thing. Let's start today's session with a story. Let's start today's session with a story. Today's session starts with a very lovely story about sodium and copper. Today's session starts with a very lovely story, a tale of sodium and copper. A tale of sodium and copper. Sodium and copper are two people. Okay, imagine sodium and copper are two people who are respectively known to everybody in their locality. Assume that sodium and copper are known to everybody in their locality. Sodium is like the benevolent king. Okay, he is like the benevolent king. He is a very Danveer kind of a person. He is a very well-known kind of a person. He is like an Ambani or a Tata. You can call him anybody. Sodium is like a very benevolent king. Okay, he is like an Ambani or a Tata, and he does a lot of charity. Okay, he does a lot of charity. Sodium is like, sodium goes into any street and everybody knows that, yeah, sodium is coming to our street. He will give us something. He'll give us something. So sodium is well respected by his subjects. In a kingdom, there are subjects. And what are the subjects for sodium? Sodium's subjects are, or you can say its kingdom is made up of non-metals. Its kingdom is made up of non-metals. So non-metals are his people. The moment these non-metals see sodium, they are always interested. Yeah, this guy is gonna come and give us something. And what does sodium give? Sodium is known to everybody to give electrons. He is very famous in giving electrons. Sodium gives electrons to every damn thing that comes in contact with him. Sodium gives electrons to oxygen. Sodium gives electrons to water. Sodium gives electron to chlorine. Anything which comes in contact with sodium, sodium is giving electrons to. Sodium is like throwing electrons to everybody. Seeing this, copper gets very jealous. Copper is like a wannabe. Copper gets very jealous. Okay. Copper gets very jealous. Okay. Enjoy this, guys. This is not exclusively for 11th. It's for everybody. Copper gets very jealous. Copper thinks that, man, like I am not so very respected. So what should I do? I should also give electrons. So copper also goes there and gives electron. But the problem is, how can copper give electrons? Copper can give electrons like this. Cu2 plus 2 electrons. And if copper gives electrons, copper then realizes that it has gotten a charge, and charge is like a headache, my dear students. Charge is like a headache, and headache is something copper would never ever want to have. Any element in the universe would not want to have this headache known as charge. Some elements are able to manage it very easily, but copper is not. So what copper does is, copper now realizes that it has gotten a charge. So this is where copper goes begging in front of other non-metallic elements that, guys, please give me your electrons. Please give me your electrons. So these non-metallic elements are like, yeah, you gave the electrons in the morning, man. Like you are coming back in the evening and asking for electrons. What kind of nonsense is this? So then these elements strike a deal with copper. Like, see, I cannot give you the electrons that you had given to us. The most that I can do with you is share electrons with you. Now copper, just because it has to get rid of its positive charge, decides that, okay, I will share electrons. Okay, I should not, but I will share electrons. Okay. So that is where, when copper interacts with chlorine, let's say you take Cu2 plus and interact it with chlorine, you end up getting something known as CuCl4 2 minus. Okay, You get something like this, and all this has is a covalent bond between copper and chlorine. Copper and chlorine. And this is because copper went too very greedy and too very enthusiastic and threw away the electrons. This is where things get different. Sodium, if interacts with chlorine, he doesn't want ki bhai, I don't want my electrons back, man. I have given it to you, enjoy. So that is where sodium tries to form an ionic bond with chlorine. So this bond is ionic and this bond is covalent. And this is where things get a little interesting. Any element which tries to form a covalent bond with a nonmetal forms something known as coordination compound. Coordination compound. Because it has to share electron, and chlorine strikes a deal, create a new chapter for me because I am doing a favor for you. So copper tells him, so okay, fine, I'll create a new chapter for you in 12th standard. 11th standard kids are not very well accustomed to coordination compounds. I'll create a new chapter for you, and that is coordination compound. And that is the topic that we would start with for our 2021 batch. That is the 12th standard batch starting tomorrow. So for our 2021 student, 12th standard students, with our first topic would be coordination compounds. Please do remember it. Please do remember it. Hit the like button if you enjoyed this story. Hit the like button if you understood that what the story is all about. The story is about greed of copper to become famous. Because if he wanted to become as famous as sodium, he ended up creating a new chapter known as coordination compounds. Okay, lovely. Thank you. So, okay, let's move on to another story. How does a physical chemist tries to impress a metallurgist? There is a physical chemist. He's a boy. He's a very, very hard-working but very silent kind of a guy. So among our chat box, there would be a lot of people who are quite interesting, but they are very, very quiet introverts. They can't talk to a girl. So our physical chemist is like that. Our physical chemist is a boy who is very, very shy in nature. He is a very shy but intelligent guy. And our metallurgist is a very pretty girl. Okay, our metallurgist is a very pretty girl. Okay, it's a very pretty girl. She's a very, very pretty girl. She is working on something. And when you like somebody, you want to spend time with them. So physical chemist stands next to the door watching the metallurgist work, and he is always thinking that like she's always tensed about something. So one day he gets some courage and goes, okay. One day he gets some girl and get some courage, get some courage and goes on to talk to the metallurgist. And he asks her, I'm sorry, but I have been watching you for quite a long time. Could you please tell me what is your issue? Why are you like a little tensed? The metallurgist tells him that, see, I have to understand the extraction process of ore, extraction process of a metal from its ore. So I have to think of a number of steps. So ore to a metal involves a number of steps, in which one of the most difficult one is the reduction of oxide. One of the steps is reduction of oxide. I cannot think my way around this. This feels a little difficult. That which element should I use to reduce something? How should I do this? So then physical chemist becomes our knight in shining armor. He becomes the person who saves the day. He takes out a sword, and the name of that sword is he takes out a sword. Okay, he takes out a sword. Okay, he takes out a sword, and the name of that sword is delta G. Delta G, or which is known as free energy. He takes out a sword which is known as free energy. What he says that, see, I can help you, and this is my gift to you. If you want to go out on a date with me later on, please let me know, but this is my gift to you. Let me give you the gift of free energy. What is free energy? So the metallurgist tells her that, see, what you are thinking, that let's say I have an oxide MO and I want to change into M utilizing a metal A, then what your objective should be is to consider the fact that is the change, can I change this A to AO easily or not? Our objective should be to think that can it undergo oxidation easily or not? It can undergo oxidation easily or not. Okay. Will it undergo oxidation easily or not? This is what I have to think. So I will tell you, my love, that please take help of something known as the electrochemical series. In the electrochemical series, there are so many elements, but there are some elements which try to undergo oxidation very easily, and there are some elements which do not try to undergo oxidation very easily. If I look at a metal's conversion into its oxide, then it will be represented like this. Now metal is a solid, oxygen is gas, and metal oxide is also a solid. This process is exothermic, but in this process there is something known as entropy. There is something known as entropy which is changing. Entropy is this. Entropy is like earlier there were gases. Now the entropy becomes less because things become solid. So our entropy is negative. Okay, delta H is also negative. So let me tell you something, that if you are interested to know the actual way of identifying this, so what he tells her, that you look at this thing, you please take this equation from me, which is delta G is equal to delta H minus T delta S. And in this equation you can see that delta H is negative and delta S is negative. So our equation looks like this. Delta H is equal to delta H plus T delta S. So therefore, if this part is negative and this part is positive, then the value of delta G will become less negative as I increase temperature. Okay, less negative. Our delta G has to be negative. Delta G, if is negative, then it is favorable. Negative means favorable. So if I increase the temperature, the delta G will become less negative, and you have to just see that which metal is, if I plot delta G versus T, which metal is on the lowest part of this plot. If I draw this plot of delta G versus temperature, which metal is on the lowest part of this plot? Okay, lowest part of this plot. So please try and understand that this is what I have to focus on. This is my gift to you. And From here comes something known as the Ellingham diagram. Can you see that the metal which is most capable of forming the oxide is at the lowest point, and the element which is least capable of forming the oxide is at the highest point? From here we can understand that any metal which is present at the bottommost position will be able to reduce all of these metals from their respective oxides. So calcium will reduce every metal which is present above it in the Ellingham diagram. It will, so this is the gift of physical chemist to his girlfriend metallurgist, and they live happily ever after. So please do remember that metallurgy without physical chemistry has got no meaning at all, because a very, very significant part of metallurgy can be explained using this delta G versus T plot. Okay, delta G versus T plot. Okay, clear? Please tell me yes if you have understood this. Please tell me yes if you understood this. This is one of the most amazing concepts in metallurgy, which we will discuss later as well in our regular sessions. Okay, chalo, lovely. Let's start the next thing. What do you think is H2SO4's most favorite dialogue? What do you think is H2SO4's most favorite dialogue? I know a lot of you people might have seen Sacred Games. That's on Netflix. And and one of the most interesting dialogues over there that is given by Ganesh Gaitonde, who is the character played by Nawazuddin Siddiqui, a very, very talented actor, is that kabhi kabhi lagta hai apne bhagwan hai. Okay, kabhi kabhi lagta hai apne bhagwan hai. So H2SO4's most favorite dialogue, my dear students, is kabhi kabhi lagta hai apne bhagwan hai. I'll translate this in English for people who do not understand this. That H2SO4 feels that it is the God. Okay, he at times feels that he is the God. Okay, at times he feels that he is the God. Why does H2SO4 feels that he is the God? Because H2SO4's feeling that it is the God comes from the idea that H2SO4 we know is capable of doing marvelous things. It does three important things. It can dehydrate. It can oxidize, and it can act as an acid. It can do three marvelous things. H2SO4 can do three marvelous things. And Rushit, I'll take your doubt a little later, beta. Please listen to this. H2SO4 does three amazing things: dehydrate, oxidize, and can behave as an acid. How do we know this? बहुत सारी चीजें हैं. There are a lot of things which exist in around us, and lot of things that you have read and will be reading which involve these three things. Because H2SO4 shows the three properties which are not shown by most of the chemicals, that they can do dehydration, they can oxidize, and they can act as an acid. So that is the reason it feels like it is the God. It is the God. And no, obviously we call H2SO4 the king of chemicals. Let's look at certain properties of it. It can dehydrate. Let's say if you take C6H12O6, it can dehydrate C6H12O6 to that extent that it will burn the glucose molecule. This is glucose. it will dehydrate it to such an extent that it will burn it, it will char it. This is charred carbon. It is a very, very strong dehydrating agent. Okay, very, very strong dehydrating agent. Okay, if you want to know oxidizing property, it is such a strong dehydrating agent that it can dehydrate HNO3 as well. In electrophilic aromatic substitution, you might have been taught by Pahul sir, and you would be learning that HNO3 is dehydrated to give nitronium ion. Nitronium ion, this you read in nitration of benzene. Nitration of benzene. So this is the property of dehydration. It can oxidize bromide in presence of MnO2 to give bromine gas, which is observed as a reddish brown vapor. Reddish brown vapor. Okay, reddish brown vapor. And acid, it can behave as an acid. You know that NaOH, if reacts with H2SO4, if I use H2SO4 over here, it will give bromine gas. So this is the property of oxidation. This is the property of dehydration. This is the property of dehydration and NaOH, Na2SO4. So that is the reason at times H2SO4 feels that, man, I am the god of everybody. I am the god of everybody. Okay, I am the king of everybody, and that's the reason we call H2SO4 the king of chemicals. We will utilize this property in learning qualitative analysis, and I'll teach you qualitative analysis in such a way, guys, that you will not forget anything. You will not forget anything. I'll teach you qualitative analysis in such a way. Okay, please. Okay. Okay. Very good. Please tell me if you understood why H2SO4 thinks that, why H2SO4's favorite line is that kabhi kabhi lagta hai apuni bhagwan hai. Why does it feels like it is the god? Because it does three important things. It does dehydration, it does oxidation, and behaves as an acid. Okay, lovely. Thank you. Thanks a lot. I understand Odia. Okay, I understand Odia, but I cannot speak as fluent Odia as I used to when I was in Rourkela. But I do understand Odia. Okay, thank you. Nishit, HNO3 is nitric acid. HNO3, well, the reaction goes like this. This is H2SO4. If I were to write the whole reaction, this is how H2SO4 reacts with HNO3. And you can see that this is HNO3. Okay, this oxygen takes up a proton from H2SO4 and it turns into HSO4 minus ion plus HOH with a positive charge, and the moment we see positive charge on oxygen, we always remove it. We always remove that oxygen. Oxygen will leave that molecule and will become NO2 plus and will give H2O. You can see that this is dehydration. Okay. This is, in fact, 12th, it's a generic topic. Yeah, this is not exactly for 12th, not exactly for 11th. However, more curated for 12th because 12th have read by the time you would be in 12th. If somebody is in 11th, by the time you would be in 12th, these things would look like, yeah, I know these things, but I have not read this in that detail. Okay. Yes, exactly. I'll teach you salt analysis. I will teach you salt analysis. Chalo. There is a mode of refining that is done in the toothpaste tube way. Toothpaste tube way. What we will do for 11th, The next session at 10:30 is for 11th standard students. Please do join it. I'll talk about it on that in that session, but please focus on this right now. So the toothpaste tube way. What is the toothpaste tube way? Okay, what is the toothpaste tube way? In most of Indian households, a toothpaste will be functional until the last bit of toothpaste is not obtained from the tube. Okay, what we do is we fold the toothpaste tube until like every bit of toothpaste comes out of it. If I would have left the job of getting the toothpaste out of that tube to my parents, they would have gotten a bulldozer and would have like pushed it over the toothpaste tube to get the last bit of toothpaste out of it. Okay, last bit of toothpaste out of it. Hota hai ki nahi? In all families you must have seen that they will just twist the end of the toothpaste until like it just comes out, the last bit of it comes out. Okay, so in fact every dad always says that, "Arey guys, please don't spam. P block class 12th, I'll teach, man. I'll teach. I'll take your questions towards the end. I'll take your questions towards the end. Absolutely, I'll take your questions towards the end. Okay, I'll take your questions towards the end. So I'll take your questions regarding what topics I'll teach towards the end. I'll explain that. Okay, there's always some toothpaste left. Every parent says that. यार मेरे parents ने बोला है, your parents would also be telling you that every bit of toothpaste tube, until and unless it is flattened by a bulldozer, has always some toothpaste left in the tube. There's a mode of refining which works on the same principle. Let's learn about it. There's a mode of refining known as zone refining. Zone refining. Okay? There's a mode of refining known as zone refining which works on the principle of the toothpaste tube. Okay? Guys, please try and understand that I teach a little slowly, and that is my you can say that people who have been to my classes would understand that I teach slowly for the reason that you can understand things properly. Okay, so please have patience, guys. You cannot cook a biryani in 2 minutes. Okay, if you want to excel at an examination, you have to give it some time. You have to give it some time. Okay. So, zone refining. What is zone refining? Zone refining is a process in which we refine silicon, germanium. Okay. And what is the purpose of doing zone refining? Zone refining is a very, very interesting way. Interesting method. Zone refining is to obtain something in almost 99.9% purity. We almost need things in 99.9% purity because you know where silicon and germanium is used. Okay, where silicon and germanium is used. Silicon and germanium is used in semiconductors. So what happens? What we do is we take a rod of silicon or germanium. Okay, we take a rod of silicon or germanium and we take a circular furnace. There is a circular furnace. Okay, this is a circular furnace. So if you look at my pen, this is a rod of silicon or germanium and I take a circular furnace like this. It looks like this. Okay, I take a circular furnace like this. This circular furnace melts this region. It will melt this region. Okay, it will melt this region. Now, what I do is I move the circular furnace a little ahead. I move the circular furnace a little ahead. If I move the circular furnace a little ahead, what will happen? This region which had already melted will stop receiving heat. If there is a circular furnace which was present over here, and if I move it over here, the region where it was already present will stop receiving heat, and I move it very slowly. I move it very slowly. The moment I move it a little ahead, what will happen? That the impurity remains in the melt while the silicon or germanium crystallizes or solidifies. Silicon or germanium solidifies. So as it moves ahead, what happens is the impurity starts moving ahead with it. So if it moves ahead, the impurity also moves ahead with it, because the molten part will dissolve the impurities. But if the but as the furnace moves ahead, the silicon and germanium will be left behind. Only the impurity which is dissolved in the melt or which is present in the molten state will keep moving ahead until and unless we come to the end of it, where we cut it and we get a strip or a rod of, or I can say a piece of pure metal. So this is the rod. The impurity keeps coming ahead. So this is like the bulldozer which your parent want to run on the toothpaste tube. This is furnace is like the bulldozer. If you actually look at it, this is how it looks like. Can you see? This is the circular furnace. This is the furnace. And this furnace melts this region. The furnace melts this region, and and then this furnace is moved downward. This furnace is moved downward. The impurity remains dissolved. The metal solidifies. You slowly move it multiple times so as to capture all the impurities in the melt. Yes, exactly, Abhimanyu. Exactly. Can you see? This is a heater or a circular furnace. So this is the recrystallized germanium silicon, and this is the base metal. So in the moving direction, the molten zone contains the impurity. So this is like the bulldozer. This is like the bulldozer, and this is the toothpaste tube. And this is the toothpaste. The impurity is the toothpaste. Okay, the impurity is somehow like the toothpaste. So the impurity will be removed. The impurity will be removed. Very, very good. Very good, Shivam. The more we play the bulldozer, the more toothpaste will come out. The more we play the bulldozer, the more toothpaste will come out. Exactly. Exactly, man. Exactly. Okay, exactly. Chalo. Now let's go on to this thing. The Pseudohalogen from Breaking Bad. Breaking Bad is an amazing series. I and Pahul love it like anything. Okay. And Breaking Bad is one of the best series ever. Breaking Bad is one of the best series ever made. The series is about a chemist who does amazing things. Okay. I'll leave it for you to discover, but can you see this? Can you see this screen grab? In this screen grab, he throws something on the floor and there is an explosion. Okay. There is something he does. He throws something on the floor and it causes explosion. What is that thing? What exactly is that thing? What exactly is that thing? That thing which you can see over here is a pseudohalogen, is a salt of a pseudohalogen. It is in fact known as mercury fulminate. HGOCN whole twice. HGOCN whole twice. Okay? HGOCN whole twice. Mercury fulminate was used as a primary explosive to detonate dynamite. It is so it's a contact explosive. It is highly unstable to shock, and it explodes immediately. However, I am more interested in this ion. This ion, OCN minus, is known as a pseudohalogen. What is a pseudohalogen? A pseudohalogen has property of halogen. Okay, it shows properties of halogen. However, it does not contain a halogen. It shows properties of halogen. It will react with AgNO3 and give a precipitate. Halogens, there is a very important property that halogens will give a precipitate with silver nitrate. Okay, silver nitrate. So pseudohalogens also display this property, but they do not have halogen. However, a very important criterion for something to be pseudohalogen is that it should have nitrogen atom. It should have nitrogen atom. So it is very vital to know that what are pseudohalogens. So if I pick cyanide, cyanide is one of the most common pseudohalogens. Cyanide is one of the most common pseudohalogens. Now cyanide is derived from HCN. So what you do is you remove hydrogen and you replace it with oxygen, and it becomes another pseudohalogen. Okay, you remove hydrogen and replace it with oxygen, and it becomes a new pseudohalogen. You remove hydrogen and replace it with nitrogen, it becomes a new pseudohalogen. You remove hydrogen and replace it with selenium, it becomes a new pseudohalogen. Okay, if you remove hydrogen and carbon and replace it with nitrogen, so if you replace hydrogen and carbon, you will replace two atoms, so you will replace two nitrogen atoms, so it will become N3 minus. All of these are pseudohalogens. All of these are pseudohalogens. Okay, so this is a pseudohalogen from Breaking Bad. We will learn about pseudohalogens when we reach to group 17. Now, please do remember, so these are the 5 amazing things that I wanted to talk to you about before I start with my actual topic. Now, coming to the actual thing, the 12th standard topic that I will start from tomorrow 9:30, 12th standard topic that I will start with tomorrow 9:30 will be coordination compounds. One of the most interesting topics and most one of the most scoring topics of I would say the whole of chemistry. Every year in JEE mains and advanced questions will come. So the first topic that I will start for 12th standard students at 9:30, which I'll go live every day until Pahul sir comes back, is coordination chemistry. And for 11th standard kids, for 11 kids, for 11 standard kids, I will start with hydrogen. Amazing hydrogen. I will talk about hydrogen as the element which we should always appreciate. I hope you had seen Sachin sir's video. Sachin sir was earlier with us in Vedantu, and he's he's an alumnus of IIT Bombay, and he's a very good friend of, he's actually a batchmate of Pahul sir. So yesterday's video that went live on our channel Catalysis, Sachin sir's rant about inorganic because his frustration about inorganic chemistry, he talked about hydrogen being a potato. You put it in palak paneer, you put it in aloo matar, aloo gobi, aloo bindi. Okay, he called it potato. So we'll talk about the potato of inorganic chemistry, that is hydrogen, for 11th standard kids. Which session? This session will be on at 10:30 from tomorrow, and I will start with coordination compounds for 12th standard kids at 9:30. Okay. No, I will not teach only coordination compounds. I will not teach only coordination compounds. I'll teach whole of inorganic chemistry. I'll teach the whole of inorganic chemistry. So if you have any doubts, do you want to ask me something? Well, Sachin is, he works in a fintech. He's not a teacher. He is a very good actor. He is a very, very marvelous actor. Yes, I will teach everything. Okay. So the sessions will be common for JEE and NEET. And there is no difference. Okay. As far as inorganic chemistry is concerned, there's absolutely no difference. Syllabus, when will it be finished? We'll finish the syllabus well in time. Slash is heavy metal. So schedule every day 9:30, coordination compounds 12th standard, every day 10:30, 11th standard topic, inorganic chemistry. Okay. Yep, up to the level of advanced. I teach toppers. At Vedantu, I teach toppers. I teach some 12th standard batches, that is Sankalp, the batches which started in April. And I was teaching Eklavya. So, the exclusive JEE advanced batch from which the results came this year. So I was busy with that. NIT Rourkela, Surathkal, NIT Mining, NIT Rourkela, both are not that great options. I will stay. Can we drink heavy water? Absolutely not. You cannot drink heavy water. Why would you want to drink heavy water? From where would you be sourcing heavy water? कहाँ से मिलेगा आपको? Okay. But if I have to be partial with NIT Rourkela, I'll go with metallurgy. Mining is a little bad option. Okay. So, what is the ideal time to complete? Let the syllabus at least start, guys. Let the syllabus at least start. We'll try to finish it as quickly as possible. For 11th standard kids, we'll try to finish it as quickly as possible. 12th standard also, we'll try to finish it as quickly as possible. Don't worry about it. We are here for you. Okay, so the Catalysis channel is here for you to cater to all needs of chemistry when it comes to like understanding things from the basics and understanding things in the most amazing way. Okay. Yep, metallurgy is there in JEE. Yep, I will teach JEE qualitative analysis before JEE Advanced 2021, and class 12th students will, the timings will be 9:30. So class 12 9:30. Class 12th 9:30. Okay, and class 11th, that will be from 10:30 every day. Okay, I am not an engineer, man. I am not an engineer. I did my bachelor's in chemistry and master's in chemistry. I'm not an engineer. I never gave JEE. Absolutely not. I never gave JEE. Okay, so chalo. It was, I hope you enjoyed today's session, and please hit the like button. Please do like, share and subscribe. Please do tell your friends that amazing things are gonna happen on Catalysis channel. I Pahul, we have amazing plans for you guys. So please ask your friends to subscribe, and please do keep hit the notification bell so that you keep getting updates about our classes. Okay, so this is Saurav Goswami signing off. Bye bye guys. Have a lovely time. We'll see each other tomorrow sharpish at 9:30 for 12th and 10:30 for 11th. Please do join my session at 10:30 now to understand should you connect the dots. What should you think when you go and start studying inorganic chemistry? Okay? Chalo. Bye bye guys. I hope you have enjoyed today.